so page 7. Okay, so by now, how many of you are comfortable with graphing one line? Graphing a line. Okay, so if you can graph one line, do you think you can graph two lines? Yeah, okay, so this is what today's lesson is about. So graphing two lines and finding out where they cross. Okay, that's nothing you haven't already done. So I'm given these two equations and I want to know where they cross. So for the sake of the review and recap, let's do two different methods of graphing the lines. So x plus y equals 4, we can put this in the y equals mx plus b form. So I'll change this, move the x over, so then I get this. Okay, this is what we've been doing for the last 2 weeks, basically, putting it in y equals mx plus b form. So what is m and what is b? Yara. M is negative x and b is 4. All right, really close. Remember, m is the number only, no x. Negative 1. Good. Okay, so very, very close. M is the number in front of the x, so negative 1. Okay. So by now, you should know how to graph this. So put a point at 4, and then your slope is negative 1. So Nicholas, from this point, what do I do? Where the slope? Yep. So if my slope is negative 1, should I go up or down? Down 1, and then 1 to the right. Right. Okay, and then down 1, 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. I can do this as many times as you want, so that you get a nice straight line. Okay. And then here we go. There's my first line. Okay, so far, nothing new. It's just given the equation, rearrange it, and then graph the line. Alright. Second method, let's do it by the x-intercept, y-intercept method that we did yesterday. So to find x-intercept, we said to let y be 0. So when y is 0, x is? Afnan? So when y is 0, get negative 2 plus 0, which is just negative 2. Okay, so what is the coordinate here? Yep. Negative 2, 0. Perfect. Okay. Similarly, if I want to find y-intercept, that means I'm going to let x be 0. So when that is 0, I have negative y equals negative 2. And so Zachary, negative y equals negative 2. So y equals? Negative 2 divided by negative 2 divided by negative 1. 2, right? And so the coordinate form would be 0, 2. There we go. Right, so negative 2 and 0, 0, 2. I have my 2 points. I can connect it to graph my second line. Okay. Then there we go. We graph both lines. All right. Have I answered the question? Long. Will I get full marks on this question? No. Why not? Right. So the whole point of graphing the two lines was to figure out what this point of intersection is. And so what is my answer here? Kevin? Yeah. 1 and 3. Yeah. Okay, and that's my answer. Okay, so example 1, straightforward, just graphing two lines and see where they cross. Okay. Now, how will this get harder is if it's in a word problem. Okay. Let's see. Nikon, can you read example 2 for us?
Lad wants to earn extra money, spends orange juice in front of his house. It costs $2 to start his business, and each glass of orange juice costs 12 cents to make. He plans to sell the orange juice for 25 cents a cup.
Thank you. Okay, so if you went grocery shopping, oranges are much more expensive. It's not 12 cents anymore, but it's actually like almost $1 out in orange. Yeah, so um, if it costs $2 to start the business and 12 cents to make each cup, can I write the equation in y equals mx plus 3 form? Okay, Cheryl, can you help me with it? Perfect. Okay, 12 cents to make, $2 for the, so probably like 12 cents for the paper cup, and then $2 for the orange. So it costs this much. Okay, and what about the revenue? I'm not talking about profit, I'm just talking about revenue, which means how much he's charging. Okay, so how much is he charging? Many? 25 cents. How do I write 25 cents? Yeah, 0.25 what? X. Perfect. We can sort each cup. Good. Okay, now that I have my two equations, I can graph both lines on the graph. Okay. Question. Oh, you want to answer? Sure, but let me just set this up first. So in this case, my independent variable is number of orange juice. So not just orange juice, because I know you guys write that sometimes. Just orange juice. Okay, it's number of cups. Okay, and then your dependent will be the costs. Now, how did I come up with these numbers right here? I didn't go by ones, because if I did 1, 2, 3, 4, 5, 6 like that, my graph is going to be very small. I'm not going to see the big picture. Okay? And how do I know to go by ones here? Well, I kind of cheated a little. Okay, you can do a table of value, basically. So when with this one, if you do a like table of value, mini table of value, okay, for my cost, when x is 0, what is y? 2, right? And I should get 2 because this is in y equals mx plus b form, and so I know my y-intercept is at 2. Okay, the other one I'm gonna do like a 30. Okay, what about when x is 30? Okay, do it on your calculator. So 0.12 times 30 and then plus 2, I get 5.6. Okay, so if I make 30 cups of orange juice, it's gonna cost $5.60. So about right here. Okay, and there's my first line. Right, this is my cost line. Okay. I'll give you guys a second to graph that first. Okay. While you guys are while some of you are copying this down, okay, you can calculate the y value for the second equation then, for the revenue line. If the orange juice are horrible and I cannot sell, what's the cost? How much do I bring in? Nothing, yeah. So the first point is 0, 0. Okay, let's say I put a lot of sugar in those orange juice. Okay, so sub in 30 in here. So 0.25 times 30, I get 750. Okay, and so I get my first point, 0, 0, and I get my second point at 30 and 750. Okay. So I get my 2 points, and I'm going to draw my line like this. Okay, and this is my revenue line. Put an arrow on it. Sure. Okay. So you see how a table of value is just like x and y intercept. All we are doing is we're trying to find 2 points using the equations so that we can plot our lines. Okay, so now that we have the graph, this point right here, what does this point look like? And just eyeballing it. Ah, just looking at it, Ariana, just looking at the point of intersection here, what does it look like? It's 17.4. Okay, I like that answer. Okay, so how many of you think that's an estimate? How many of you think it's just it's the exact answer? Right. So who thinks it's just an estimate? Yeah. So when we're graphing, it's all only an estimate because it depends. Like if my line was a little curved or it was I made the point a little off, it's not exact. When do you do exactly? How do you find out exactly? In grade 10 when you do the algebra way. Okay. The good thing is in grade 9, you guys only solve using graphing. So the questions that you get whenever it asks you what is the intersection point, the grade 9 method is by graphing. Grade 10, chapter 1, method of substitution, method of elimination. All right. So what does this 17 and 4 represent? James. How much orange sell until you don't lose it? Until not like you know that. Good. I like that answer. But so what's the unit? So 17 what? So like on the assignment, I'm gonna ask you what the point of intersection mean. And when I ask that, I don't want you to I don't want you to define it. I don't want you to say where two lines meet. The point where they cross. That's not what I'm looking for. I'm looking for the meaning in terms of the context of the question. So Kavya? 17 juices for $4. Right, 17 cups. And then $4. Excellent. For $4. 17 cups for $4. Ah, okay. And then this part right here. This is the I am gonna for sure ask you this question on the assignment. So if Ahmed sells 20 cups, if he can sell 20 cups, is he making money or losing money? Making money. Making, right? Because revenue is higher than cost. What if I put a lot of sugar in it and I can sell 50 cups? Making more. Making even more, right? Because your revenue line is much higher than your cost. What if it tastes really sour and the oranges are really bad and I was only able to sell 5 cups? Yeah, so your cost is higher than your revenue. So then you're losing money. So now here's the $1 million question. Should he keep going or quit or what? All right. So how many of you say Quit while you're ahead. Run away. Dump those oranges. Quit. All right. How many of you say keep going? You're making money. You'll be a millionaire one day. All right. Who says depends? Ah, okay. Ben, depends on what? The weather. Neighborhood and all that. Yeah. Okay. How many exactly? How many customer does he need? 17, right. Okay, so I like how you guys are thinking business wise. You're thinking, oh, okay. A lot of you said keep going because it doesn't seem like it's a big loss if you even if it's not. But those are good business class answer. Okay, in math class we want mathematical answer. So in this case we have our three-part answer. So Afnan, just wait a second. Let me just write this out. So if he can sell less than less than 17, what should he do? Quit. Yeah, quit. All right. If he can sell more than 17, keep going. All right, keep going. And then if he sell exactly 17, all right, there's a special name for this point. Yeah, I heard it, Jeffrey. Break even. Right, it means, as Jeffrey said, you don't make any money, you don't lose any money, you just wasted your like your life. Yes, you just wasted your time squeezing all those oranges. Okay, so this part right here, I'll even highlight it. Okay, on the assignment, it's gonna ask you for the three-part answer. This is the three-part answer. Right? So I don't want I don't want answers like depends on the neighborhood, depends how nice your neighbors are. Like I'm not depends how sweet your orange are. Okay, so I'm not looking for those answers. I'm looking for the mathematical answer based on your point of intersection. Ethnic. Your audience? Yeah, so that's why I mean I don't want the business answer. I want the mathematical answer. Yeah, so this is the mathematical answer based on your point of intersection. Okay. Uh, example three. Example three. I don't need you guys to solve it, but you guys need to know how to set this up. All right. So Rosa has $7.85 in dimes and quarters, and in total she has 50 coins. Write an equation, yeah, to for this problem, but do not solve. All right, so let's define some of our variables. What does D represent? Dimes, but all right, be more specific. Number of dimes, that's right. Okay, and so Q would be? Number of quarters. Ah, okay. So it is very important because when you just say D is dime, Q is quarter, doesn't mean much. Okay, so your first equation deals with the number of. So if I have 50 coins in total, who can come up with that first equation? Isabella? Perfect. D plus Q equals 50. Okay. D plus Q equals 50. Your second equation deals with the value of the coins. Okay, yeah. So 0.10 represents time. Good. And let's do 0.10x plus 0.25y. And it equals not 50. Remember, it's the value. What's the value of those coins? 7. Sorry. Right. $7.85. Right. Okay. But at the beginning, we already set D and Q instead of DQ instead of x and y. So in your second equation, you want to use the same variables as well. But good. All right. Good job. And so and again, we don't need to solve this because, well, you can solve this by graphing, and then but in grade 10 you guys will learn a better method, which is method of substitution elimination, and you will definitely see questions like this. Chapter 1 is all about this, so don't forget. If you're gonna forget anything in grade 9, don't forget this. You are gonna see it again, like right at the chapter 1. Okay, last example right here. Okay, thus, do these two lines cross at -1, -5? Okay, so one easy way to do it is graph this, see where they cross, if they cross at -1 and 5 or not. What's another way? What's the mathematical way? Kavya? You can replace it with the coordinate. Right, you can replace it with the coordinate. So for example, if I put in -1 here, 3 times -1 minus 2, do you get -5? Yep, you do, right? So, yeah, so 3 times -1 is -3. -3 minus 2, you get -5. So yep, that means this point is on this line. Okay, Ariana, if I plug in -1 in here, what's -1 times -1? Plus 2? So it's not -5. So what does that mean? Right, so it means that this point is not on this line. So if this point is on the first line but not on the second line, can they intersect? No. All right, so it has to be on both. Okay, so in math, this is the terminology that we use. If -1, -5 satisfy both equations, then it is an intersection point. And we use the word satisfies. So how would you say that? It satisfies both? Yeah. It satisfies both equations, so it is the intersection point. But if it only satisfied one, then it's not the intersection. Okay. So as I said, this lesson, you're gonna see it on the assignment. You're gonna see it on the assignment. You're gonna see it on the assignment. So make sure you try these 2 homework pages. If you take a look at the questions, oh look, we did selling orange juice here. What's for homework? You're selling lemonade. I wonder what we're selling for the assignment. Whoa. Okay. And when is your assignment? Do you guys know? Monday. It is posted. It is Friday. Nothing's on Monday. Oh, that was last week. That was yesterday. So Friday. Technically, we could have it tomorrow because you guys know it early. But I want to make sure you guys understand. So Friday, and it's gonna be based on this. What's on Monday though? Anything on Monday?